Okay, ladies and gentlemen, we are going to be doing some quick notes for Unit 3 on page 50. So I want everybody to go to page 50. Unit 3, Learning Target number 6. And these notes are equivalent ratios. So we've talked about equivalent a lot. So go ahead and write that down, equivalent ratios. And somewhere at the top, I want you to go ahead and highlight equivalent. And I want you to remind yourself that equivalent means the same. They may look different, but they are the same. Okay, and I had you go ahead and glue this in. You're going to glue it on the left-hand side of your paper, your graphs, okay? And we're going to have two parts to this. So you're going to have, oops, not a red dot. You're going to have two parts to this. You're going to have your tables. And on the other side of the page, we'll be doing some unit rates, okay? So let's go ahead and get started. Make sure you have this title down as well as equivalent ratios, and make sure you have the same, right? Don't forget ratio just means, it could mean a fraction. In this case, that's what we're going to be working with. Or it could mean with a colon, or it could mean with the word to, okay? So make sure you have that down just so you know that we're looking at something that's the same. And in this case, we're actually going to be focusing in on fractions, okay? A ratio, which is a fraction. So in this case, our first table, you've seen this before. They're asking for the missing value. And we did this on our homework. We're multiplying by 4 every time to get 8, to get 12, and to get 20. So in this case, our ratio would be 4 times 14. 4 is 16, okay? So I know you know all of this, but I wanted to show you what I mean by equivalent ratios. So if you have a highlighter, it would be a good idea to highlight maybe a couple different colors if you have them, which you should, okay? I want to show you something really quick, just so that you can get an understanding of what an equivalent ratio is. For instance, for this first green one, I'm going to write the ratio 2 to 8. And then I'm going to write the ratio 3 to 12. And then I'm going to write the ratio 4 to 16. And then I'm going to write the ratio 5 to 20. And what we are learning from these tables is that all of these are equivalent or the same. And you might be wondering, well, what does that actually mean? Well, let me show you something when we simplify. If I were to simplify the bottom and the top by 2, I would have ended up getting 1 out of 4. Or if I simplify this bottom and top by 3, I'd end up getting 1 over 4. If I simplify this by 4, I would end up getting 1 over 4, right? These are all what we call GCFs also. You've learned that. Where I find the GCF of these two numbers, and this would be 5, so it would be 1 out of 4. Either way, they are all equivalent expressions. They might look different, but at the end of the day, they are the same. And you'll get this anytime you're working with tables where you see a pattern. For instance, for this table, we multiply times 4. We multiply this times 4 because 11 times 4 gives you 44, and 2 times 4 gives you 8. So I know I have to multiply this 1 times 4, which will give me 4, and 5 times 4, which will give me 20. Okay, so these are all things we've already learned. You already know all this well, but I wanted to show you why we call them equivalent expressions. So I'm kind of rushing through the tables because you guys have actually done every one of these tables for your homework. If you've been doing your homework, which is a good reason why you should be doing your homework. Okay, so let's talk about this. We have this last one here. If you didn't already do it, something times 4 gives me 80. Well, I know that's 20. All right, let's write our equivalent expressions. The first one is 1 over 4. My second one right here is 2 over 8. My third one is 5 over 20. My fourth one is 11 over 44. So I'm just taking the x over the y. And my last one is 20 over 80. Again, these are all what we call equivalent ratios. They're all the same. If I were to simplify all of them like I did above, they would all be equivalent ratios. They'd all be the same number. In fact, they'd all be 1 out of 4. Okay, so make sure you put that title here to equivalent ratios. All right. And because we know they're equivalent, just like we did this last time on our homework, we know 0 plus 12, in this case instead of times, is 12. 5 plus 12 is 17. 10 plus 12 is 22. 15 plus 12 is 27. 20 plus 12 is 32. And they're asking for 25 minutes. So 25 plus 12 is 37. So we could easily make some equivalent fractions. We have 0 out of 12. We have 5 out of 17. We have 10 out of 22. And remember, these are all equivalent. We have 15 over 27. We have 20 over 32. And we have 25 over 37. Remember, these are all equivalent expressions. Okay? Or ratios, expressions, same thing. Equivalent ratios. So now let's transition to how to find equivalent ratios when they're not in a table and when you are missing a piece. Okay, so it's very much like what you see here. We're going to transition now into equivalent ratios. So on the other side, let's go ahead and create equivalent ratios a different way without tables, right? So let's go ahead and get started. For instance, pretend you have the ratios 4 over 6 equals 18 as the denominator, but I don't know the numerator, okay? You can do it one of two ways. You can do it with patterns or with an equation, okay? You're going to learn both ways and you're going to use both ways, so it really doesn't matter which way you would like to start using it, but you're going to use patterns or equations, okay? So if one feels more comfortable, please go ahead and do it that way. All right, so let's go ahead and rewrite this over again. Let me show you how to do it with patterns. This is the way that you learned with a table. You literally could create your own little table really quick with this, because watch this. All right. Oops, let me get black there. 6 times 3 equals 18. So I know 4 times 3 has to equal 12. Okay, it's literally you having an X and a Y table. All right. You're just looking for a pattern. 6 times 3 equals 18, so 4 times 3 equals 12. And I guarantee you it's always going to be multiplication when you're looking for this type of pattern. Okay? Same thing over here with this equation. So maybe you want to find it using an algebraic equation because you're going to have to learn this anyways. And maybe algebra makes more sense to you. So in this case, I don't know what this number is, so I'm going to put a variable, okay? We will put a D for I don't know, okay? All right, let's go ahead and get started. This is what we call cross multiplication. Because you have this equal sign in the middle, we could cross multiply these. So 6 times D is, I don't know, I have no idea, so I'm just going to put 6 times D. Now I'm going to put my equal sign. Now let's cross multiply the other way. 18 times 4. Well, I know 18 times 4, when I multiply it out, is 72. Oops. 72. Okay? So now all I have to do is figure out 6 times what equals 72. And you could literally put into your calculator 6 times 1, 6 times 2, 6 times 3, until you get to 72. You could literally do that. But a faster way is just do the opposite real quick. Instead of multiplying, just divide 72 divided by 6. Okay? And if you do that, you end up with 12. Either way, you notice the answer is 12. You're going to have to learn both ways. I know this way right here may make a little bit more sense to you right now, but you will be using the algebraic way when we get to percents and to rate and unit rate, which is very, very soon. Okay? So that cross multiplication is important for you to at least see. All right, let's go ahead and try one more just so you guys have a good amount of practice with it. Okay, so for this one, let's switch it up a little bit. Let's put it on this side, the missing one, the missing value. Okay, so we are going to put a 10 here, and over here we're going to put a 5, and over here we are going to put a 3. Okay, let's go ahead and get started. We will do it both ways. So if we're trying to find, I know these are equivalent ratios because they have an equal sign in front of it. So I have to see, how the heck do I know if they're equivalent? Okay, so let's go ahead and figure out, we're going to do it with patterns, and then we'll do it with an equation. Okay, so we're going to do patterns, and then we're going to do it with an equation. Let's do a pattern first, because that seems to be the fastest way for most of us since we've been working with these tables. So if we do it with a pattern, if we do it with a pattern, it's much like our table that we've been working with, right? We could literally make a table out of this thing, right? And we know in this case, we're going to have to go backwards because you see the 10 is bigger. 5 times 2 is 10. So 3 times 2 is 6. That's our pattern. We just went the other way because our box was on the other side. All right, 5 times 2 is 10. 3 times 2 is 6. Oh, that's pretty easy. Okay, let's find the equation now. Let's do it that way. We have, I don't know, so I'm going to put a 10 there, right? I mean a D there. Over 10 equals 3 over 5. All right, remember, if you wanted to learn the algebraic way, then that is more than wonderful because you're going to have to learn it anyways. But let's go ahead and get started. I always start with the side with the variable, which is 5 times D, which I have no idea what that is, so I just write it out. And then I go to the second one, which is 10 times 3, which gives me 30. So now all I have to do is figure out 5 times what number gives me 30. Well, if I don't know that, remember, I just can put the bigger number on top and divide. I can do the opposite of multiplication, and that gives me 6. Either way, my answer is 6. Okay, what I want you guys to do is go ahead and flip your paper to the back, because we are going to be talking about some equivalent ratios really quick. Okay, so flip it to the back of 50. All right, to the back of 50. So to the back of page 50, that's where you should be right now, so that we can talk a little bit more about equivalent ratios. Okay, equivalent ratios are something that are the same, but they might look a little bit different. All right, we're going to test some really quick. Right, for instance, if you have 10 t-shirts for $20, or let's see, 5 pairs of pants for $10. Let's see if these ratios are the same. So we have 10 over 20, and we have 5 over 10. And we need to see, are these the same? Well, that's pretty easy. I'll show you how to work that out. I just go pretend it's a table again, okay? In this case, I see my smaller numbers 5 and 10 over here, so I'm actually going to go backwards. I say to myself, oh, well, 10 times 2 equals 20, and 5 times 2 equals 10. So they are equivalent ratios. They are equivalent ratios because they are the same thing. You see a pattern there. Or if you don't like that way, you can do it a different way. You can say, okay, if 10 t-shirts cost $20, 20 divided by 10 is $2. And if 5 t-shirts cost, or pairs of pants cost $10, 10 divided by 5 is 2. Either way, they have the same rate, which is 2. You notice that, okay? So you can do that either way. You'll be seeing those on your homework, so I wanted to touch on those briefly.